Good morning, students. Welcome once again to another further maths class. I remain your teacher, Sridhat Osai. Today we want to continue from where we stopped last lesson. Last lesson we treated differentiation of trigonometric function, exponential and logarithmic function. And we have also exhausted all the methods you can use in solving differential equation. Today we want to look into this type of differentiation called implicit differentiation. Now, before we start differentiating, let us understand the meaning of implicit functions. What are implicit functions? Implicit functions are functions with mixed variable. In other words, where you cannot express one in terms of the other. The variables are usually x and y. Like if you have y is equal to x squared plus 3x minus 4, this expression, y is already the subject. So it means all that we have been treating, they are explicit differentiation. This is implicit. So example of implicit function are the ones you cannot express one as the subject of the other. So x plus xy is equal to y squared minus 3x. If you take a look at this equation, you cannot identify which one is the subject of the other. So this is a perfect example of an implicit function. So differentiating implicit function is not the business of today. So we want to solve example. Let's start with example 1. Differentiate implicitly the following functions. Okay, now if you look at these two equations, they are both implicit functions because x and y are scattered across the equation. The simple approach you are going to be using is not different from our regular differentiation, but just an addition of one step. And the step is that you are going to recognize y Now this equation, you are going to recognize y as the function of this expression, as if it's the subject of the equation, and differentiate regularly. Our regular method of differentiation remains use the coefficient, the power to multiply the coefficient, reduce it by 1. So ordinarily if you differentiate y, that is going to give you 1. So anytime you differentiate y, henceforth for implicit, you multiply the y dx. Plus, if you differentiate x, that will give you 1 is equal to, now this is 2xy. This is, bring the 2 out. You are going to differentiate xy using chain rule. Now this is going to be chain rule. That is holding x, differentiating y. When you differentiate y, that will give you 1 times the y dx. Since I differentiated y. Now plus, differentiate your x by holding y. If you differentiate x, that is going to give you 1. So if you rearrange this very well, 1 times the y dx will give you the y dx plus 1 is equal to 2x dy dx plus 2y. You have to make dy dx the subject of this equation. So from this point, dy dx plus 1 equal to 2x dy dx plus 2y. If you make dy dx the subject, it means we are going to bring this one over here, or you can make an alternative. You can take dy dx to meet this. Whichever method you follow there, you are still correct. So dy dx minus 2x dy dx will be equal to 2y minus 1. So So these are the dy dx. You factorize dy dx. You have 1 minus 2x is equal to 2y minus 1. So divide through by 1 minus 2x, because I just need to make dy dx the subject of the equation. Dy dx means the gradient of the function. So dy dx now will be 2y minus 1 all over 1 minus 2x. So this is the derivative of the function stated earlier. So this is number 2. We want to solve number 2. Don't forget what I told you. Differentiate y. If you differentiate this 2y, that will simply give you 2. But because it is y, you attach your dy dx plus differentiate y squared. That will give you 2y. Then attach your dy dx is equal to x. You know, I told you you will use product rule here. I hope that's what I told you in the example 1. Please product rule, because it's x times y. X times y is product rule. So hold x and differentiate y. If you differentiate y, that will be 1. I don't need to write it, because 1 in multiplication does not change the partner. That is identity element. 1 is an identity element in multiplication. So this is going to be times dy dx plus hold y, differentiate x, that will be 1. So it's not going to affect y, so I don't have to write it. So this is what we have. You gather all the dy dx together. I have dy dx here, dy dx here, and I have dy dx here. So this is 2 dy dx plus 2y dy dx minus x dy dx is equal to y. Y is the only term that does not have dy dx. Now, the sole reason for doing this is we want to factorize dy dx out. So if I write dy dx as a factor of those 3 terms, I have here 2 left, I have here 2y left, and I have here minus x left is equal to y. I will divide this out here. So dy dx will become y all over 2 plus 2y minus x. So this is just how to differentiate functions. So this is the answer. With these 2 examples, I am sure you'll be able to approach a question if I send any to you. So I want you to attempt this question, differentiate implicitly the following. These are the 4 questions. With the example I solved earlier, you will be able to solve this question. Thank you for watching. Remain blessed. See you next time.